morning, Dragons. We're going to do AIM page 16, GCF with distributive property and relatively prime. I can use the GCF of a set of numbers in order to write equivalent expressions. So this also goes with our current unit in algebra. I can determine if a set of numbers are relatively prime by calculating the GCF of that set of numbers. Relatively prime was an important vocabulary word from the beginning of the year. I'm going to show you a strategy that I showed you yesterday, and we'll show you again later today on page 17. This is going to help you understand how to do the GCF in a faster way. So, you can find the GCF using the rainbow method, or you can do the GCF using prime factorization. We're going to get there in just a minute. Okay, looking at this first. Rewrite the following expression in the form A times the quantity of B plus C. We talked a lot about this. This is like the distributive property. We talked about how that was a factor and that was a factor. The sum of terms was its own factor. This is like a coefficient to the sum of terms. We did all of that in Carnegie. Here is a statement. They want us to take this statement and rewrite it like this. But what they want right here is the GCF. That's what they want right there. So, step one is finding the GCF between 63 and 49. You can use any strategy that makes sense to you. So you could use the rainbow method. Rainbow method is exactly what it sounds like. Like if we have 63, it'd be like 1 and 63. Does 2 work? No. Does 3 work? 3 and what? Let's see. 3 and 21. And then 4. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 and 9. 8, and then we're back at 9. Okay, so you've got these factors for 63. And then for 49, you would have 1 and 49. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7, 8, 9, 10, 11, 12. Sometimes I check 16 because he tends to fall. Nope, I think this is it. So this would be the rainbow method strategy. This was a 49. I just miswrote it. Or you can use that strategy I showed you yesterday. So the strategy yesterday was using a factor tree. And there were some tools to this. Here we go. We've got 63. We're going to break it down. We're going to do 7 times 9. 7 is prime. 9 is not prime. We've got to break down that branch more. 3 and 3. Okay, those are the factors, the prime factors of 63. We're going to repeat the process. So, with 49. Easy peasy, 7 and 7. All right, when you're looking for the GCF, you're looking for all the common factors. And this we did on, we looked at this strategy, I know we saw it yesterday. I just got to find what page we saw it on. Here. We had to find the common factor. The steps are also broken down here on page 17, which we'll go over. Okay, so the prime factorization of 49 is 7 times 7. The prime factorization of 63 is 7 times, and I'm leaving a space on purpose, times 3 times 3. I'm leaving a space on purpose because we're only supposed to find the ones that they have in common. They only share 7. Now, had they shared more, we would multiply them together, but we don't share, they don't share anymore. So that leaves us with a GCF of 7. Well, let's look back at our rainbow. Let's see if that's reasonable. Yep. the greatest common factor that they share is, in fact, 7. So you could use either strategy and get there. Now, GCF will go to the outside. It will go here. What does that look like in terms of things we've done before? It looks like the distributive property using the box method, aka the area model, where it's B times A plus Y. Well, B is now your GCF. So that's going to be 7. Now we know that B times A is going to be 7 times somebody, because somebody was 63. Where's that 63 coming from? The original. And this one was 49. So that means B times Y was 7 times somebody. That was going to equal 49. So 7 times who would get you 63? It would be 9. 7 times who would get you 49? That would be 7. So this is how you're working backwards to figure out what goes inside here. This represents the B in the area model. This represents the A plus the Y, the two inner factors. The 9 and the 7 is the sum of terms. So 7, your GCF, is like the coefficient to the sum of terms. We're going to prove that this works. So if your GCF is 7, which represents the B, and this is your A plus Y, and we just said 9 and 7 is the sum of terms, so it's going to work. You would do 7 times 9, which would get you 63. Oops. We're expanding it out. Hold on. We're going to do 7 times 9. That's this. If you lost me there, that's this. And then we're going to do 7 times 7, which is 7 times this 7. So that's this multiplying with this now. Two different colors. Try to help you there. Well, the 7 times 9 is 63. That's the product. And the 7 times 7 is the 49. That's the product there. So B times the sum of A plus Y is the same as B times A plus B times Y. Take a look at that. It's pretty cool. Now, it's okay if you didn't catch all this, because we can do the rainbow method. And in fact, I will do the rainbow method off to the side here so you have it on your notes. So, had we gone the rainbow method, let me go in a different color. If we had done the rainbow, we would have done 63. Was 1 times 63, 3 times 21, and 7 times 9. If I had done 49, I would have done 1 times 49, and then just 7. I put a dot under 7 because it represents a 7 times 7. And the GCF, if we went this method, would have been the 7. So I just took the work that we did on the scrap piece of paper and stuck it in the notes. So that is how you take a simple addition problem and rewrite it as an equivalent expression with a coefficient times a sum of terms. So we're talking about the distributive property. We're talking about a coefficient times a sum of terms. That is all straight up from the algebra unit. Okay, lastly, we're going to look at the very bottom here for the notes. Revisiting an important vocabulary word, our friend Mr. Relatively Prime. Find the GCF between 37 and 81. Okay, we can do that. I'm going to do some rainbows since we're not that familiar with the prime factorization strategy. So I'm going to do a rainbow for 37. I've got 1 and 37. Boom. Done. I'm going to do a rainbow for 81. 1 and 81. 2 doesn't work. 3 does work. 3 times 27. You may not have been familiar with that one. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 works, but it's 9 times 9, so I'm going to do my little dot. Now, what can be said about these two numbers? What is the GCF between the two numbers? The only thing they have in common is 1. The GCF between the two numbers is 1. Two numbers that do not have any common factor other than 1 are called relatively prime. Fell off my page there. There we go. Relatively prime. Another common example that I have seen on several ERGs and on several tests is, and I'm just going to stick it in your notes so you can have seen it before. You might have even done this in a practice problem in the past. Is they'll say, what is the GCF between 16 and 15? I'm not really sure why this one comes up a lot. I think because they both are, neither one of them is prime independently. So you're looking for some kind of commonality between their factors. So if I were to do a factor rainbow with 16, it would look like 1 and 16, 2 and 8, 4 and 4, no 5, 6, 7, okay, so 4 repeats itself. If we were going to do one for 15, it would be like 1 and 15, no 2, but we could do 3 and 5. So when you compare the two lists here, you would see that the only thing that they have in common between this list and this list is also 1. So this particular example is also relatively prime, but what makes this one special compared to this one is 37 was already prime on its own. Neither one of these were prime on its own. Both of these contained other factors which made them composite. So if he's composite, you're looking for any commonality between the two sets of factors, and the only commonality between the two sets of factors is 1, making them relatively prime between each other. So I hope you enjoyed that lesson. That's one of my favorite pages because it incorporates a couple different units together and really pieces together some of the missing puzzle pieces. Okay, thank you. We're going to do another page later today. I appreciate you watching the videos.